Hello, I'd like to show you a novel way of writing G-codes. My method will allow you to make a rough sketch of the object that you'd like to cut. It will take care of any adding, subtracting, multiplications, and divisions that you need. It will also let you change your dimensions in the blink of an eye. This method has helped me to better understand G-codes, and I hope it helps you too. My method involved using a spreadsheet. Before you stop and switch channels, thinking that it might be too difficult, watch this video to the end, then decide. The program I use is Microsoft Excel, an excellent spreadsheet program, but I could have used another program such as LibreOffice Calc, which is free to use. Let's begin by drawing a 1" by 4" rectangular pocket. Highlight the cells using your mouse to represent the shape of your object, using the paint icon to paint the highlighted cells any color you like. To create borders, highlight the appropriate cells, right-click your mouse, choose Borders, Cells, Borders, then Outline, and click on OK. To change the width of any column, right-click on the top of the column, choose Column, Width, and type in a number. Next, insert the pocket dimensions. You can use inches or millimeters for your dimensions. With my mouse, I place my cursor on a cell at the side of the workpiece. Type in a number and press enter. Then repeat for the bottom dimension. I chose to have a 1/4" border, so I add 0.25 to the bottom, tops, and sides of my pocket. The default accuracy for each cell is 0 decimal places. Notice when I typed in 1 and 4, the numbers had no decimal places. To ensure all my dimensions are not rounded off, I set all my cells to 2 decimal accuracy by holding down the keyboard's Control button and A button at the same time. I right-click with my mouse, select Format Cells, left-click, I choose Number, select the number of decimal places, and click on OK. To add double arrows to your dimensions, left-click on Insert at the top of the screen, select Symbols, choose Symbol again, then select the double arrows found in the subset Arrows, click Insert, then Close. Let's create a formula to calculate the overall width of the workpiece. Left-click in an empty cell, press the equal button, left-click on the bottom border dimension F14, press the plus button, left-click on the pocket height dimension F8, press enter, the plus button again, left-click on the top border dimension F2, and press enter. By double-clicking on the overall height dimension, R8, you will see the highlighted cells that make up your formula. Press enter when you are finished looking. Repeat the process for the length of the workpiece. To make pocket dimensions stand out, I place the pocket dimensions in the center of the pocket and the thickness of the borders. If the basic dimensions are changed, the cells with basic dimension formulas will also change. The center of the cutter is positioned at x0, y0. If I move the cutter to x.25 and y.25, the center of the cutter moves to the edge of the pocket. When I move the cutter to x.5, y.5, the trailing edge of the cutter will be touching both the left and bottom border lines. If I move the cutter to 4.0, y.5, the leading edge of the cutter will be touching the right border, and the trailing edge will be touching the bottom border. Moving the cutter to x 4.0, y 1.0, the leading edge of the cutter touches the top and right side border. When the cutter is moved to x.5, 1.0, the trailing edge touches the side border and its leading edge touches the top border. The formula for the coordinates to move the cutter to each axis, starting at the bottom left, y equals cutter radius plus border thickness, and the x equals cutter radius plus border thickness. The bottom right corner formulas are y equals cutter radius plus border thickness, and x equals cutter radius plus border thickness plus pocket length minus cutter radius. The reason why we subtract the cutter radius is because we want the leading edge of the cutter to touch the border line. The center of the cutter has to be located 0.25 inches less than the pocket length. The top right formulas are y equals cutter radius plus border thickness plus pocket width minus the cutter radius, and x equals cutter radius plus border thickness plus pocket length minus cutter radius. The top left formulas are y equals cutter radius plus border thickness plus pocket width minus cutter radius, and x equals radius plus border thickness. Now let's enter our formulas. Using colored fonts is a great way to stay organized. I wrote a G-code to the right of our workpiece. Only the letters and numbers can be used in G-code. The arrows are just to help us visualize the toolpath. It is a very basic G-code. That should work with most machines. If not, it can be modified if needed. I always make an error cut when running GCode for the first time. For this project, I raised my cutter about an inch above the top of my workpiece, then set Z-axis to 0. Once I am satisfied that the program is working properly, I lower my cutter somewhere in the pocket until it kisses the top surface of the workpiece. Then I reset the Z-axis to 0. The first line with instruction G54 is to ensure that my CNC program uses work coordinates, not machine coordinates. M5 is an instruction to turn the spindle on, and S2500 to set the spindle speed to 2500 RPM. The fourth line, G1 F45, sets the feed rate to 45 inches per minute. Some of you with CNC routers may prefer to write G0 Z1.0, a rapid instruction that moves your axis at maximum speed. Z1.0 moves a spindle 1 inch above the work surface to prevent collisions with clamps or other objects. Adjust this dimension higher if necessary. The next line, X.5 and Y.5, are coordinates where the CNC will position the cutter by moving the X, then the Y-axis at 45 inches per minute. An alternative way of doing this is to have X.5 and Y.5 on the same line. This allows the machine to move diagonally as a crow flies until the cutter is positioned at X.5, Y.5. It's a quicker method, but the chance of collision is a little higher. F30Z minus 0.2 are instructions to slow the feed rate to 30 inches per minute, then plunge the cutter down 200 thousandths deep, slightly less than a quarter inch. The feed rate will stay at 30 inches per minute for the rest of this program. X4.0 is an instruction to position the center of the cutter at X coordinate 4.0. The next coordinates result in a perimeter cut in the pocket. When the cutter is once again positioned at X.5, Y.5, the spindle plunges down to Z minus 0.4, slightly less than a half an inch, then makes another perimeter cut. Once this cut is completed, the spindle will plunge down to Z minus 0.6 and make a final cut. Instruction Z0.1 raises the spindle until the cutter clears the top of the workpiece by 100 thou. The final instruction, M3, turns the spindle off. Don't worry, the program will still function if you turn your spindle on and off manually. If I change the dimensions of the workpiece, the GCode coordinates change automatically. There are many different methods to zero X and Y axis before cutting. One method is to use a straight edge to align the leading edge of the cutter to the bottom edge of the workpiece, then set the DRO coordinate to minus 0.25 inches. A second way is to align the leading edge of the cutter to the top edge of the workpiece, adding 0.25 to the pocket's top Y coordinate. A third way is to position the cutter in a convenient X.5, Y.5 location on a larger piece of wood. Run the program, then cut the workpiece out with a saw. The same methods can be used to zero the DRO's X-axis. Making only perimeter cuts is a quick, rough, and tough cut. The pockets, bottoms may have to be cleaned up slightly, and the side pressure when cutting could possibly damage your borders depending on the thickness of your border. As a precaution, I would prefer to make the first cut in the midpoint of this pocket, leaving thinner cuts along the long sides of the pocket creating less stress on thin borders and no need to clean up the bottom of the pockets afterwards. In the midsection of the pocket, I entered the words mid y equals in a cell. Next to it, I created a formula to calculate the center of the pocket simply by adding the small y and large Y values, then dividing the two to find the center. The top line of the code contains the words interior cut inside of closed brackets. CNC programs skip to the next line when closed brackets are used. Putting a description in closed brackets is an easy way to stay organized. The first cut begins at x.5, y.75. The cutter plunges down to the first cut. The machine positions the cutter at x 4.0, y.75. Then the cutter makes a perimeter cut. Stopping when the cutter is positioned again at x 4.0, y.75 again, the cutter is plunged down to z minus 0.4. The machine positions the cutter to the left at x.5, y.75, makes a second perimeter cut. The machine stops when the cutter is positioned again at x.5, y.75. The cutter is plunged down for its last cut. The machine positions the cutter to the right at x 4.0, y.75. Then the spindle raises up 100 thou above the work surface and the spindle shuts off. I created a code to cut the outside of the workpiece, leaving 1/8 inch tabs. The first two cutting paths are very similar to the interior cutting path. To cut tabs, I created a mid-X formula. During the final cut, as the cutter nears each midpoint, the spindle lifts up from minus 0.6 to minus 0.55, travels 5/8 of an inch before the cutter plunges down to minus 0.6 again, creating 4 tabs 1/8 inch wide. Since my stock is 3/4 inch thick, tabs are not necessary. But if I were making an exterior cut in a piece of melamine, which is typically 0.65 inches thick, I would definitely prefer to have tabs. To create wider pockets up to 2.5 inches, you can add 2 more cutting paths at 1/3 and 2/3 the sum of the Y coordinates. To create overlapping cuts, add 2 more cutting paths at 1/4 and 3/4 the sum of the Y coordinates. The last pocket cutting I want to show you features a top and bottom pocket separated by a 0.25 inch border. Pockets are ideal for storing drill bits, mill cutters, reamers, screwdrivers, gauge pins, punches, and so on. By now, you must be wondering how to load GCode from a spreadsheet. It is easier than falling off a log. Just highlight the top 2 cells and drag the mouse down until you highlighted the entire column. Right-click, select Copy, open a word processor such as Notepad, and paste. Save your work and you're ready to go. Again, I highly recommend running any GCode with the cutter in thin air high above the workpiece. If there are any errors, hopefully they will become apparent before you ruin your workpiece or damage your machine. That is how to write GCode using a spreadsheet. I hope you agree that it helps to visualize the finished product, to keep organized, and best of all, change any dimensions quickly and easily. Thanks for sticking around to the end. Don't forget to give me a like and subscribe. In my next video, I will show you how to create a drill bit tray to organize drill bits in one slide-out drawer using a spreadsheet program. I will leave instructions how to receive a copy of my spreadsheet in the description below. Thanks for watching.